It takes the information that the satellites are giving it, with the satellites are saying, hey, this is where you are. And the GPS knows, well, that's not where I am. I'm actually over here. And it calculates an X, Y, and Z error. And then it feeds that error to the drone. You're listening to the Drone Advantage podcast. This is your first class ticket to aerial intelligence. Construction is one of the most complex and fast-moving industries in the world, but it's also one of the most inefficient. Construction projects are notorious for delays, cost overruns, inefficiencies. Whether it's inaccurate site data, mismanaged material, or unexpected rework, the industry is losing billions of dollars every year, just due to avoidable mistakes. The bigger the project, the harder it is to keep track of everything. Materials, labor, equipment, progress, and that's where things start to go wrong. Site managers and contractors have been relying on these manual inspection techniques that you guys are all familiar with for decades, and it's been working. While it gets the job done, though, it's slow, it's expensive, it's full of blind spots. These manual inspections take hours, sometimes days. Site survey work can stretch on for weeks. And then small mistakes that are happening while these inspections and surveys are waiting to get processed snowball into major rework, which end up then costing thousands, and in worst case scenario, sometimes millions of dollars to fix. But what if I told you that a single drone flight can capture more accurate data in 20 minutes than a full survey crew could do in 2 days? That's exactly what's happening in construction today. Drones are changing the way projects are managed, providing real-time, highly accurate data that helps contractors and project managers and developers make better decisions, track progress, and reduce costly mistakes. I'm Rob. I'm a commercial airline pilot, FAA certified drone pilot, and the owner of the Tampa Bay franchise of Blue Nose Aerial Imaging. Welcome to the Drone Advantage podcast, where we break down how aerial imaging is transforming industries and how you can use drone data to work smarter. Today we're diving into how drones are revolutionizing construction site monitoring, keeping projects on track, reducing costs and eliminating inefficiencies, and boosting profitability. Here's what we're covering today. First, we're going to go into the biggest challenges that construction firms face when it comes to site monitoring, and why traditional methods, these manual data collection methods, are holding them back. We're going to talk about how drones are solving these challenges, the types of data that drones provide that make construction workflows more efficient, and finally, we're going to break down the financial impact of drones, where they cut costs, save time, and help construction companies stay ahead of their competition. By the end of this episode, you're going to see why more construction firms are integrating drones into their workflow and why companies that don't are leaving money on the table. So when site managers are out walking sites, they're looking for several things. First, they're looking for just they're monitoring the progress of the project and making sure that things are on time. They have to take that and document it and report it back to the shareholders. Whether those shareholders are remote project managers or investors, the next thing they're doing is they're looking for errors in the work. They're also looking for any safety hazards or violations. On large, complex sites, this can take hours. Sometimes it takes days. This just means that the time that it takes to walk the site, because it takes so long, hours or days, it really delays the capture of the data that is being looked for. Any errors that have been made, any safety concerns that exist, or safety violations that exist, it's just taking longer to capture that data. And the problem is the longer it takes to capture that data, it just means that those errors really start to snowball and compound. And the longer it takes to discover an error, the more expensive it is to fix it. I mean, just a miscalculated foundation pour can cost tens, if not hundreds of thousands of dollars to fix. Any rework that needs to be done, just delays the project. On average, the cost of project delays is $7,000 a day. And on really big projects, it can be $50,000 a day. Statistically, on average, just rework costs 9% of the project's budget. That's huge. Imagine if regular aerial monitoring just saved you 1 day of delay. Would you think that was worth it? Leave your answer in the comments below. And if you're listening to this on an audio-only platform, head on over to thedroneadvantage.buzzfeed.com and text the show. And then, of course, there's the off-site project managers or investors who are just getting written reports and maybe some ground-based photos. That really doesn't allow them to see the entire project. Aerial photos gives them that bird's eye view that they're looking for. And I can tell you in my experience, when off-site stakeholders receive aerial progress monitoring images, they love it. And of course, for survey work, the same challenges exist, right? Taking days or even weeks to collect project data. And how much does surveying cost? Thousands of dollars per site. Of course, when an actual site survey is necessary, drone imaging or drone operations do not replace that. Most drone pilots, myself included, are not licensed surveyors. Most of the time, site managers can get the data they need without having to pay a survey team to do an official survey. I mean, I was talking to a project manager a couple of months ago, and he told me that one of his biggest nemesis is material management. So he was really excited when we were talking to learn about how quickly and efficiently and accurately drones can measure stockpile volumes. It turns out that his firm faces the same challenges that most firms do. And that is really that it's just so difficult to keep up-to-date and accurate stockpile volumes, making it nearly impossible to track usage over time. He told me that manually measuring stockpile volumes is generally inaccurate, that he gets a measurement and finds out later that it wasn't right. And of course, by the time he finds that out, it's too late. Materials have already been ordered, and either they were under-ordered or over-ordered. Under-ordering materials just causes further project delays, right? And then over-ordering materials causes waste and project overruns. He was really surprised to learn that in the hands of a skilled drone pilot, stockpile or volumetric measurements are usually 98% accurate. And he told me that he estimates that depending on the size of the project, he can save $10,000 to $50,000. It's $50,000 per project. This was really a no-brainer for him. Statistically, on average, 10 to 20% of materials either go unused or unaccounted for. And this is really just because of poor and ineffective tracking. But things really don't need to be this difficult. Let's talk about how drones are solving these problems with real-time aerial intelligence. I mean, using drones reduces the time it takes to do an inspection by 50% or more, sometimes as much as 80%. And this means that if there are any issues, like errors that have been made, that stuff is going to get found faster, discovered faster. And the sooner it gets discovered, the less it costs to fix. But one of the things that I hear, one of the concerns that I hear from construction site managers are they're concerned with the accuracy, the positional accuracy of drone mapping. And, with proper capturing techniques using industry best practices, the geo accuracy can be survey grade on these drones, down to 1 to 3 centimeters of positional accuracy in the X and Y axes. And, the Z axis or the vertical axis is generally the least accurate axis. And I always estimate that whatever my error is in the X and Y axis, my error in the Z axis is going to be about 3 times that error. So if I have a 2 centimeter error in my X and Y axis, then I expect that my vertical axis is probably going to be around 6 centimeters off. But how do these drones get so accurate? I mean, the GPS in a drone is really only as accurate as the GPS in your cell phone, right? It's only accurate to 1 to 3 meters, really just a couple of meters of positional accuracy. And remember that if our if our z-axis is 3 times that, that could be 6 meters off vertically. And that's just not good enough. That's not good enough for any kind of measurements. We can't do stockpile measurements with that. We can't do linear measurements with that. We can't do, digital elevation models. We can't, that's not data we can use. So how do drones tighten that accuracy up? And they do that using a technology called either RTK, which is real-time kinematics, or PPK, which is post-processing kinematics. Basically what's going on is you're connecting the drone to a network that's feeding the drone positional inaccuracies. So how does it get positional inaccuracies? How does whatever is giving it this data, how does it get the data? And the way it works is you have a GNSS receiver, basically a GPS receiver, that is at a surveyed location. And so this receiver knows exactly where it is on Earth. And it is receiving GPS signals from satellites. And these GPS signals are oftentimes distorted, they're inaccurate because of atmospheric conditions or solar flares or whatever the case may be. And since the receiver knows exactly where it is on Earth, irrespective of the GPS signal that it's getting, what it does is it takes the information that the satellites are giving it, with the satellites are saying, hey, this is where you are, and the GPS knows, well, that's not where I am, I'm actually over here, and it calculates an X, Y, and Z error, and then it feeds that error to the drone, and then the drone takes that information and updates its position in real time. And then when it writes the metadata onto each photograph that it takes, it writes the corrected position data. That's RTK, or real-time kinematics. PPK, on the other hand, is what you would use if, say, you can't connect to a network because you are somewhere that doesn't have cellular service, for example. So if you don't have cellular service and you can't connect to a network, you can't do these real-time corrections. So what happens in PPK is the drone actually writes its raw GPS data into the metadata of the photos. And then we go back in post-processing and we go ask the receiver, hey, what was the positional error during these times that I was taking these photographs? And we take that positional data, or that positional error, and we feed it into the photogrammetry software, and it will then rewrite the position metadata on each photo and correct its position. This gets our photo accuracy, or our positional accuracy on our photos, down to just centimeter level. And of course, the next thing we need to kind of talk about is, when we talk about accuracy, is what is accuracy and what are the different types of accuracy, because there are 2 different types of accuracy. And what I just explained really tightens up what's called the relative accuracy of the photos. So the photogrammetry software will now build an orthomosaic map that is highly accurate relatively, meaning each photo is very accurate compared to all the other photos in the set. So this relative accuracy really allows us to get very accurate linear measurements and also volumetric measurements. Now, if I'm going to take this map now and lay it onto the Earth, it may be off a couple of centimeters or maybe even a couple of inches one way or the other on the X, Y, and Z axis. And if we need those maps to be as accurate as possible on a global scale, that's called absolute accuracy. So if I can take that map and put it on Google Earth, for example, and the roads line up exactly, that would be absolute accuracy. Absolute accuracy is what we would need if we wanted to overlay that orthomosaic into a CAD or a BIM software to compare the as-built with the planned build. So how do we achieve absolute accuracy? Well, we do that by using what's called ground control points and checkpoints. So ground control points are going to be visible points So the camera is going to be able to pick the points up. You'll see them. You'll see the ground control points in the orthomosaic map. And they're going to be points that have a known location. So they have been either surveyed by a surveyor, or most drone pilots can lay ground control points and then get their position with a GNSS receiver. So then once the orthomosaic map is built and you can see the ground control points, then what we do is we upload the exact position of each ground control point in the photogrammetry software. The photogrammetry software is then going to take the position that it thinks the ground control point is at, and it gets that from the metadata of the photos, and it shifts it over and corrects that position to the known location of the ground control point. So we put down several ground control points. The exact positioning and number of ground control points is going to be highly dependent on the size of the project and the terrain of the project. But we put these ground control points down, and then we tie them all to a particular location. The photogrammetry software then will shift every one of those ground control points, a centimeter here or 2 centimeters there, to the exact position on Earth that we told it that it was. The second thing we're going to use, because using ground control points is great to position the map, but it doesn't do us any good as far as verifying that the position is correct, because what we're doing is the software is forcing each point to move to where we're telling it that it is. So what we're going to do is we're going to lay checkpoints down. And these checkpoints are exactly like ground control points with one big difference. So we're going to lay the checkpoints down. They're going to be visible from the air just like the ground control points are. And we're going to tell the photogrammetry software exactly where each one of these points are. But when we tell the software that this is a checkpoint and not a ground control point, what happens is the software does not then tie that point to the location. So it's not going to physically move the point. What it's going to do is it's going to calculate the error between where I'm telling the software that point is and where the software thinks that point is. It's these checkpoints then that's going to allow me to verify the absolute accuracy of my map. So we have the ground control points, which are ensuring the absolute accuracy, and then the checkpoints, which are verifying the absolute accuracy. Now, keep in mind, I just told you about two different kinds of accuracy. We have absolute accuracy and we have relative accuracy. If we want stockpile measurements, if we want digital elevation models, and if we want, linear measurements, we don't necessarily have to use ground control points to get accurate measurements, because the ground control points are ensuring absolute accuracy, but the RTK and the PPK are really what's tightening up that relative accuracy. And it's really all of this accuracy enhancing gee-whiz technology that allows us to get these orthomosaic maps that can reliably be used for measurements and digital elevation models. Digital elevation models are used for, grading and drainage planning and earthworks and cut and fill planning. And this data really is going to be available at sometimes as low as 30% of the cost of a traditional survey. And it's going to be in your hand in just hours instead of days. And now that we've got the data collection or the site inspection automated, now we can take these orthomosaic maps and overlay them into your CAD or your BIM models and make real-time as-built versus as-planned comparisons. Every time we map your site, we're going to fly the exact same flight plan. So when I go map a site and say that, I've drawn in my flight planning software, this is my exact route. When I fly that route next week and the week after and the week after, the photos that it takes are going to be the exact same positions. And that eliminates any variability from week to week, making every single map identical. And this is really the value in the aerial data collection, is this automation that we use to make sure that every map is exactly the same, is positioned exactly the same. And this is really what's great about aerial data collection, is because these flights are automated and it eliminates the human error, and every one of these maps is exactly the same, we really have no variability when it comes to tracking progress. So from week to week to week, every map that you get is taken with exactly the same parameters, so they can all be overlaid on top of each other, and And with these layers, we can look at exactly what has changed between last week and this week. And then if we do see any errors, we can correct those errors immediately before they become very expensive. Okay, so in my last episode, I went through all kinds of different kinds of aerial data collection technology. I went through, RGB cameras and multispectral, thermal, LiDAR. If you didn't watch that one and you're not familiar with the different types of data, you should watch that one next as soon as we're done with this one. So of all these technologies, the most commonly used for construction site monitoring is RGB. These super high resolution photos are going to give us all the data we need to accurately track our project and our progress and do our reports and document and all the things that we need to do. So we use these photographs and hundreds and sometimes even thousands of them to create these orthomosaic maps. And I went over in my last episode how these photos are kind of stitched together, and I went over the orthorectification process and all of that and what that all means. So if you're not familiar with that, head back to the last episode when you're done with this one and check that one out. So we take these hundreds or thousands of photos and we stitch them together to make this orthomosaic map, which we can then turn into a 3D model or digital elevation models. And, we use these things for, earthworks planning and progress and just a ton of things. Now, if you need the highest level of accuracy in your digital elevation models, then you're not going to want to use RGB. RGB is accurate, and it is plenty accurate enough for most applications. But if you need to be down to centimeter or sub-centimeter accuracy in your digital elevation model, you're going to want to move to LiDAR imaging or LiDAR terrain mapping. LiDAR really is the gold standard for grading and drainage planning, and it virtually eliminates miscalculations. And all this is fine, but it's all just gee whiz stuff if we don't talk about how it saves money, because that's really what it's all about. Does drone imaging or aerial intelligence capture save construction companies money, or does it not? And resoundingly, the answer is of course it does. But how much money is it actually saving? Well, that really depends on how big the project is. So we're going to go strictly off percentages. So these are just industry averages across the country. So if we go just off of percentages, the data really tells us that we're going to reduce material waste by 10 to 20%. We're going to reduce rework costs by 20 to 30%. We're going to reduce surveying costs by 30 to 70%. And we're going to speed up progress monitoring by 50%. All of this leads to reducing delays, wasteful spending, increasing safety, which reduces liability, and ultimately even reduces insurance costs. Hey guys, if you're listening on a podcast app, please don't forget to head over to the podcast website. This is where you're going to find a link to text the show. Give me any feedback that you have. I'll respond to anything you tell me. Also consider hopping over to YouTube. Now, while you're not missing any information, I do record all of these in video, and I do throw things up on the screen sometimes just to kind of give a visual for what I'm talking about. Again, you're still getting all the information on the audio podcast, but sometimes it's nice to see, kind of put a picture with an idea, and pictures are worth 1,000 words. And if you're on YouTube, make sure you subscribe to the podcast, click the bell to receive any notifications. Make sure that you comment. Those comments really help us out. Also, I'm going to respond to every single comment. Tell me what you think about the show. Tell me what you'd like to hear. Are there any episodes that you'd like to have come up? Any topics that you want to hear about? Just leave them in the comments. Have a question for me? Leave it in the comments. Are you a project manager using drone imaging? Throw that in the comments. Tell me how drone imaging is helping your workflow out. The great thing is YouTube comments can be like a community where we're all helping each other. Just a reminder, I'm going to be releasing a new episode every other Sunday. And I'm doing it that way so you can listen to the episodes on the podcast app on your way to work on Monday. Make sure you subscribe so you don't miss any. Thanks for watching to the Drone Advantage podcast, where we're keeping business decisions at 400 feet and below. We'll see you in 2 weeks.